Program Director, please allow me to state that all protocol has been observed. People who know me don't really see me nervous. Today I'm nervous. This is a big day. I recognize the Honourable Minister, Acting Vice Chancellor Hughes, CEO of China Digital Innovation Hub, all speakers who have really nailed it, and I'm standing here humbled today to hear how everything has been perceived, distinguished guests, colleagues, farmers, investors, members of the media, ladies and gentlemen, distinguished guests, good morning. Remember, 7 years ago, two men stood in the pyrolysis lab at this university, right here at Houston, arguing over an older reactor that refused to do what it was supposed to do and was acting up. Then there was no keynote address. There were no high positioned people present, no media. There was grease on their hands, and the deadline that had already been missed, and a pilot plant that was not cooperating. That moment, unglamorous, stubborn and costly, is where new carbon really began. I tell you this not because I enjoy embarrassing stories, but because I want every farmer, every investor, every government official in this room to understand one thing before I say anything else, and that is what you are about to see demonstrated today was not built in a boardroom. It was built by people who refused to stop. Where we started. In March 2019, the Botswana Innovation Hub, now BDIH, took a calculated risk. They funded a small, unknown company called Pyrocarbon Energy to build a proof of concept pyrolysis plant which processed poultry litter. The grant, as stated, was 1.5 million pula. The goal was simple in words, but brutally difficult in practice. Take agricultural waste, specifically poultry litter, which Botswana chicken farmers produce in enormous quantities and largely regard as a problem, and convert it into something valuable. The technology is called pyrolysis, the thermochemical conversion of organic material in the absence of oxygen. Feed in biomass, get out bio-oil, combustible gas, and biofuel. Each of those outputs has value. The bio-oil can be used as a fuel, the gas can power the plant itself, and the biochar, that dark, stable, carbon-rich material, can be returned to the soil as a fertilizer, as an amendment that improves water retention and crop yields for years. Science was understood. The engineering challenge was to make it work reliably. In a containerized format, at low cost, and operable without a team of PhD engineers on site. We achieved that. Every milestone in the VI funding agreement was met, an industrial design was registered, the proof of concept unit was built, it was commissioned, and operates at this very moment in time on this very campus. To the Botswana Innovation Fund and BDIH, thank you. That investment is paying off today. In this, and it will continue to pay off for decades. What we built and why it matters more than ever. Ladies and gentlemen, I need to pause the history lesson for a moment, because there is something happening in the world right now that makes what we are launching today far more urgent than we anticipated 2 years ago. Look at the headlines. The conflict in the Middle East, sustained, destructive, and with no clear end, is reshaping global supply chains in ways that reach far beyond the battlefield. Two of those ways directly strike at Botswana, at Southern Africa, at every farmer, large or small. The first is energy. Disruptions to the Middle East oil and gas supply routes volatility. For farmers who rely on diesel, for irrigating pumps, for tractors and other equipment, and for rural communities that depend on diesel generators, every price spike is a crisis. Botswana is a net energy importer. That is structural vulnerability. The second is fertilizer. This is the one thing that keeps agricultural economists awake at night. The Middle East and the broader region, through Jordan, Egypt, via disrupted supply from the Russia-Ukraine conflict, supplies a significant share of the world's nitrogen and phosphate fertilizers. When those supply chains fracture, fertilizer prices increase. Now let me tell you something about what biochar does to the soil. Applied in modest rates, biochar improves soil water retention by up to 20%. It increases cation exchange capacity, meaning that the soil holds nutrients rather than letting it leach away. It reduces the quantity of synthetic fertilizer needed to achieve the same crop yield. And unlike the fertilizer crisis, from materials that farmers already have on their property at zero input cost. This is not a coincidence of timing. This is why we built what we built. The commercial product, the CPP2, the unit that you will see demonstrated today, is a proof of concept machine, our first generation plant. And it is our 2-ton per day workhorse that proves the engineering and the economics. But the product we are here to sell is the CPP2. Our commercial scale containerized pyrolysis plant, rated at 5 metric tons of feedstock per day. The CPP2 is packaged into a standard ISO container format. It ships by road or rail to any location or ship. It is fully automated. Operators load feedstock and manage product offtake. The control system handles the rest, everything in between. It does not require a power grid connection because it generates its own electricity from the syngas. It can be relocated when feedstock resources shift. It can be replicated, deployed in multiples to several severe larger operations without the risk and capital intensity of building a single large centralized plant. A 5 tons a day single CPP processes roughly 1,825 tons of feedstock per year. It produces approximately 450 tons of biochar annually, enough to treat over 200 hectares of degraded African soil. It produces bio-oil and gas that together delivers significant energy value, and it eliminates a waste disposal problem that every large poultry and crop processing operation in this region is currently paying to manage. The CPP2 is a revenue-generating asset that solves 3 problems simultaneously: waste management, energy dependency, and soil fertility. There is not another machine on this continent that does all 3. So who should own one? Let me speak directly now to different people in this auditorium. Firstly, to the poultry producers. You generate tens of thousands of tons of organic waste every year. You pay to dispose some of it. You give away more of it. And the remainder creates odor, fly, and groundwater problems. The CPP2 converts that liability into bio-oil for your generators and incinerators, biochar for your soil, and gas to power the plant itself. It pays for itself. To the agricultural input companies and cooperatives, your customers are being squeezed by fertilizer prices they cannot control. Offer them biochar, produced locally from their own waste at a fraction of import cost. This is a product with a 30-year tailwind behind it. The government and the DETP, Botswana has set ambitious targets for reducing agricultural imports, improving food security, and building a diversified, knowledge-based industrial economy. The CPP2 is manufactured here in Botswana. It generates intellectual property that is Botswana-owned. It creates skill, technical employment in fabrication, operations, and maintenance. And it generates export revenue. We already have orders in the Middle East, where, ironically, the same geopolitical instability that is threatening global fertilizer supply is also creating the most urgent market for sustainable energy and soil technology. And then to investors, SFC, who unfortunately are not able to attend today, has signed agreement with us. But what I will say here in public is this: the CPP2 is not a development stage product. It is a proven technology moving into commercial production. The reference plant at Richmond Chicken Farm will be operational within this year. Middle East orders are placed. Our fabrication facility is being established. The question for investors is not whether it works. You will see it working in 40 minutes. The question is whether you want to be part of it at this stage or watch from the outside. What views may possible? Before I close, I want to say something to this institution, to BT. Botswana made a decision some decades ago to build a University of Science and Technology in Palani. Some people questioned the location, some questioned the cost, some questioned whether Botswana even needed such a thing at all. The containerized pyrolysis unit that you are about to watch run The technology that has attracted international investment, that has been published in peer-reviewed journals, that has registered intellectual property in Botswana's name, that technology was conceived, developed, and tested on this campus in partnership with views, researchers, and students. That is what a University of Science and Technology does. It does not just teach, it builds. To Professor Shaman and the views community, the New Carbon story is partly your story. We are grateful to share this platform with you. And we look forward to continuing that partnership as we scale. The invitation. Ladies and gentlemen, I have one ask before I hand the program back to the program director. In 30 minutes, you are going to walk out to the demonstration area and watch a containerized pyrolysis plant process agricultural waste into valuable products before your eyes in real time. When you walk back in, I want you to be thinking about 3 questions. Where does my operation or my client's operations produce biomass waste today? What is that waste currently costing me? Or what value am I currently leaving on the table? And could a CPP2 sit on my land or my client's land within the next 18 months? The answer to that last question is possibly yes. Please find me or find Michael, my co-founder, before you leave today. We have a commercial team ready to have that conversation. The world is changing fast. The Middle East is burning. Fertilizer prices are not coming down. Energy insecurity is not going away. These are not abstract geopolitical concerns. They will reach every farm gate in Botswana. They will arise sooner than most people expect. We built the CPP2 for exactly this moment. The only question is, who will be ready when it arrives? Thank you.